In this video, we're going to look at the code to run the gripper with the lead screw in the continuous rotation servo. So first of all, in the platformio.ini, you want to make sure you have use this text right here. You can copy and paste it. It's on Canvas, and then we're going to, of course, include the RB1001 lib.h. And to read an analog input, we're going to use this library right here, ESP32 analog read. And then we're also going to use a timer, and I'll explain a little bit more about that in just a minute. So we have give the pin numbers here, and with the continuous rotation servo, you give it a number between 0 and 180. 90 or about 90 is supposed to be the motor is stopped, and then 180 is full speed in one direction, and 0 is full speed in another direction. So I have you have to kind of play around with that. I find once the servo warms up a little bit, it seems like 95 is a good number to use to have it stop. And at 90, it seems like it starts to drift a little bit. Yours may be a little different depending on the servo. And then when I have it rotating so that the jaw goes down or opens, I have that set to 50. It could be set all the way to 0, right? It could be set a lot faster. And then when I'm pulling it up, I have it set to 130. Again, it could be set all the way up to 180. And then I'm setting a print delay here, defining that variable, and just defining some other floats. So with my potentiometer, when the jaw is open it could still open a little bit more, but when it's open about how much I want it to go for this test, it's reading about 1 volt. And then when it's closed on the plate, it's reading about 3 volts. Okay, so here we have to set up the an object for the analog read. I'm just calling it linear pot, and then an object for the servo, which I'm just calling jaw servo, and then we're also setting up an object for the timer, and that's where kind of call the timer print timer, and it's going to have a delay of 500 milliseconds, as you can see right here. And so again, I'll explain a little bit more about that in just a minute. So we attach the linear pot to the pin we're going to use for that, and the same thing with the jaw servo, the pin that we're going to use for that. And then we'll go ahead and start the program. So I'm just going to start out by just writing to the servo to stop it, delay 500 milliseconds, and then read the pot and print the initial value of the pot here. And then we're going to start the servo. We're going to start it down. So we just do again, jaw servo.write and servo jaw down, which that number has already been defined. And then as long as the linear pot is reading a voltage bigger than the jaw open pot voltage, right? The jaw open pot voltage is 1 volt, then we're just going to let it keep running, moving down. Okay? And so here's the use of that print timer. And this is kind of nice. If the print timer is expired, then we go ahead and print the voltage. And this is set to, the print timer is set to 500 milliseconds. So this is an easy way so that, if we wanted to print every 500 milliseconds, we can just use this. And what it does is whenever you read it, in other words, whenever I call this print timer dot is expired, if it comes back false, in other words, it hasn't expired, it just keeps running, right? If it has expired, so if it's either at 500 milliseconds or later, then it comes back true. And when I call it, the print timer dot is expired, then it starts it again. So in other words, the timer stops when it reaches 500 milliseconds and just waits to be called. Once it's called, it returns a value of true, it has expired, and then restarts the printer, the timer. So you can set up as many timers as you want using this class. Just set up as many objects as you want, printer objects, and they're it's non-blocking essentially. So it's a lot better than using a delay, the delay command. All right, so anyways, this keeps running and prints every half second, right, every 500 milliseconds, until the voltage drops below the jaw open voltage, and then it continues on. In this case, we're going to write to the servo and tell it to stop. And then these statements print out the voltage, the current voltage, and waits 5 seconds and prints out the voltage again. I'm just trying to see if there's any drift, just to make sure the servo has actually stopped and it's not moving. And then once that time period goes by, then we start the jaw moving up or closing. And then it's the same exact thing. Like while the voltage is less than the jaw closed pot voltage, which is about 3 volts. Again, I just adjusted it so it was somewhat tight on the plate, 3.05 volts. Okay, and it just keeps moving up until that's not true, until the voltage is bigger than the jaw closed pot voltage, and then it stops the servo and prints out the values, waits 5 seconds, prints out the values again, just to see if there's any kind of drift. Okay, so I just want to show you how I have this hooked up. So here's our continuous rotation servo, and here's this wire, and I have it plugged in down here. And the servo is driven by, the black should be on ground, the red 5 volts, and then the servo control line is pin 33. And then 34, this yellow line right here, I have this going into this breadboard, and then I have the potentiometer plugged in for that. So you have to be careful here. The potentiometer, remember, we're going to be reading. That's not an output. With a servo, the control line is an output from the SP32, but from the potentiometer, the white wire is going to be an input, and we want to make sure that doesn't exceed 3.3 volts. So we're going to power the potentiometer with the black is ground and the red is plugged into 3 volts. Okay, so. Okay, so we're going to go ahead and run the code now, and you can see I haven't started yet, but the pot is printing out like 1.86 volts right now, and we have the gripper here ready to go. So let's turn it on, see what happens. Turn the power on. All right, so now you can see that the drawer is opening up, and it gets to this part, and you can see there's a little bit of drift right there, so I probably need to adjust the stop position. And you can see at the bottom of the screen it says bottom 1.0, and now the voltage is going up. All right, it's going up, and I'm just going to get this position. You can see that it will grab, and we're getting close to 3 volts right here, and it's gripping the plate. There's that 3. You can see that it's holding it quite firmly, the plate, and still not much drift, still at around 3, and now it's going to start. Voltage is going down, it's opening back up. Okay, and this will, voltage is going back down to 1 volt, and there we go. And that delays 5 seconds, and we're going to check it again. Still at right about 1 volt, and yeah, and now it's voltage is going back up to grab it again. So, all right. So, anyways, that gives you an idea of how this code works, and the way that you can use things like the timer and set up the analog read and whatnot. So